This program is virtually identical to the previous program with one major exception. This demonstrates the do-while loop as opposed to the while loop. You'll note that the syntax has the do at the top of the loop, while now the while is at the bottom of the loop. The condition being tested for is the same as being tested earlier, in that the num less than or equal to 10. The fundamental difference between the while loop and the do-while loop is that the do-while loop is considered a post-test loop, which means that the loop is guaranteed to be executed at least once, and then it will be tested for to see if it should continue or not. If we compile and execute this program, you will observe that the output is identical to the previous example, and that it produces the numbers 1 through 10, and then displays the phrase loop has ended, which is being displayed outside of the do-while loop, just as it was in the first version. The programmer, of course, just like we did in the previous example, changed the value of num, changed the initial value of num, changed the increment of num, and could also change the value that's being tested for. The key difference here is that I could create a condition such as num being initially equal to 11. Now, num equal to 11 is a value which is not consistent with this condition. That is a false condition. However, when this program is executed, it will display the value of num of 11 and then tests for the condition after it has added 1 to the num, and therefore it will be 12. So let's observe this. And note that the program does produce one line of code that says num is equal to 11 and then exits the loop. And this is because this is considered a post-test, and that the loop itself will be executed at least once before the condition being checked for is checked. With the pretest, that is the while loop version, if we had given num the initial value of 11, then the while statement at the top of the loop would have prevented the loop from executing at all. Let's return to demo 21 and make that change. I have now retrieved demo 21, which is our original example of the while loop, and I'll create an initial value of 11 for num. This should force this condition to be false immediately, and therefore will prevent the contents of the loop from being executed. Let's test that program. I'll go ahead and save those changes for now. And as you can see, the output is nothing, simply that the loop has ended. And this is the key difference between a pretest and a post-test. With the pretest, the condition is checked for first. With a post-test, as you saw a few moments ago, the condition is being checked for after the loop is executed at least once. I have now returned to demo 22, which is our do-while example. And let's change the value, or the operator, of less than or equal to greater than. So now our condition is num greater than 10. We have an initial value of num as being 1. The loop will be executed at once, guaranteed, since it is a post-test loop structure. The question now becomes, is this condition true? That is num greater than 10? And of course, 1 plus 1 of 2 is not greater than 10. So the loop will not continue. We'll recompile and then execute. And as you can see, it printed the value of 1. It added 1 to num, which became 2, but it did not display it because the loop never re-executed. That is, it did not go back up and display the value of num. Another possibility that exists with loops is to create an infinite loop. And this is very easy to cause to happen. For example, if I give the initial value of num the value of 10, this program will then accept that as the value of num, display the number 10, add 1 to num, making num 11. Then it will check for this condition, num greater than 10. Well, of course, 11 is greater than 10, so it will continue and then display that number. It will add 1 to num again, making it 12. Once again, num will be greater than 10. In fact, this is an infinite loop because our condition is now guaranteed to always be true, and that num is greater than 10 since I initially gave it a value of 10 and added 1 to it. Let's watch what happens when we have an infinite loop. You'll note that it is not considered a compiler error because syntax-wise everything is fine. But logic-wise we do have a problem. As you can see, the program continually runs. One way of stopping this is simply clicking close and then clicking yes to terminate this program. And then it should come back without a problem. But obviously this is a program that you do not want to be executed by the user, as it will create an infinite loop and create other problems. There are many variations of the while and the do while loop that you should experiment with.